Welcome to Density and Specific Gravity. This video is part of a series in Foundations of Engineering by Conceptual Calculus. First, we look at mass and volume. Mass tells how much matter is in an object. It can also be defined as the resistance to acceleration. The base unit of mass in the United States customary system is the slug. In the international system, it is the kilogram. Other units of mass include pound mass, ton, and gram. Volume is the amount of space the object takes up. The base unit in USCS is the cubic foot. In SI, it is the cubic meter. Other units of volume include gallon, liter, cubic inch, and cubic centimeter. This leads us to density, which is mass divided by volume. Base units of density are slug per cubic foot in USCS and kilogram per cubic meter for SI. Other units of density include pound mass per gallon, kilogram per liter, and gram per cubic centimeter. Density is a derived dimension. Density is often represented by the Greek letter rho. It looks like a P, but it makes the sound of an R. Density is mass over volume. Volume is the cube of length, so density is mass over length cubed, or mass times length to the negative third power. To put this in a dimensional analysis chart, use the exponents on the dimensions. Length is raised to the power -3, mass is to the first power, and the other fundamental dimensions are not involved. Here are some densities of common substances. Gases have low densities. Helium has a lower density than air, which is why helium balloons float in air. Liquids have higher densities than gases. Water is emphasized here and will be important later. Olive oil and honey have densities that are similar to water. Mercury is much denser than other liquids, and even denser than many solids. Most types of wood have lower densities than water, which is why wood usually floats on water. Ebony is an unusually dense wood. It has a higher density than water, so it sinks. Metals are denser than wood. Aluminum has a particularly low density for a metal. Gold and platinum are very dense. Specific gravity, also known as relative density, tells how the density of a substance compares to the density of water at 4 degrees Celsius. 4 degrees is specified because water changes density slightly with temperature, and it is at its most dense at 4 degrees Celsius. To use specific gravity, it will help to know the density of water in different units. SI was designed to make this simple. The USCS numbers are messier. My students do not have to memorize these values. They will be given on all tests. Other students should check with your instructors. Here's an example involving olive oil. The density of olive oil varies slightly with the variety, but is about 7.51 pounds mass per gallon. To find the specific gravity of olive oil, it will help to have the density of water in the same units, pounds mass per gallon. Remember that specific gravity, also called relative density, is the density of the olive oil divided by the density of water. Since both densities are in the same units, the units cancel, and we find that the specific gravity of olive oil is 0.9. The specific gravity is less than 1 because olive oil is less dense than water. That is why oil floats on water. To better understand what this means, consider balancing a cup of olive oil against a cup containing water. It takes 9/10 as much water as olive oil to make the scale balance, because 9/10 is the specific gravity of olive oil. Now we consider honey. The density of honey varies a bit with the variety, but is usually around 1.4 grams per milliliter. We find the density of water in those same units, 1 gram per milliliter. We divide to get the specific gravity. Since the units are the same, they cancel, leaving the specific gravity of honey as the unitless and dimensionless number 1.4. This is greater than 1, which means honey sinks in water. If you have ever put honey in a cup of tea, you have seen this happen. Because honey is more dense than olive oil, it takes more water to balance a cup of honey than it took to balance a cup of olive oil. We need 1.4 cups of water to balance a cup of honey because the specific gravity of honey is 1.4. Now we repeat this example using mercury. We have the density of mercury in kilograms per cubic meter, so we find the density of water in those same units. To get the specific gravity of mercury, we divide and cancel the units. This gives the specific gravity for mercury of 13.6. This is much greater than 1, so mercury sinks rapidly in water. To balance a single cup of mercury, we would need 13.6 cups of water. Finally, we look at a different kind of problem. We want the mass of this aluminum cube, which is 6 inches on each side. We know that the specific gravity of aluminum is 27. The dimensions of the cube are given in USCS units, so we find the density of water in USCS units. If you don't have the mass per cubic inch handy, you can use the mass per cubic foot and convert. We know that the specific gravity of aluminum is the density of aluminum divided by the density of water. Multiplying through by the denominator, we find that the density of aluminum is the specific gravity of aluminum times the density of water. This gives us the density of aluminum as 1,685.6 pounds mass per cubic foot. We know that density is mass over volume. Multiplying through by the denominator tells us that mass is density times volume. We have the density of aluminum. The volume of the cube is the length of a side raised to the third power. Instead of 6 inches, we write the length of a side as 0.5 feet. This makes the cubic feet cancel, and we are left with a mass of 210.7 pounds mass. I hope this has been helpful. Conceptual Calculus thanks VIVA, Virginia's Academic Library Consortium, and New River Community College for their generous support.